sun affects our windows on that. This is really a passive solar analysis, or what we call a sun study. And the eaves are one of the biggest things we can do to affect the performance of our house just by the design of it and make it work well. It can keep it cooler in the summer, it can keep it warmer in the winter if you do your eaves correctly. They come through a whole system here. Normally we look at it on these 2 days, December 21st and June 21st. Why would we do that?
Seasons.
Summer and winter solstice, that's when the sun's at its highest or its lowest, right? Everything in between is what we're going to see in our climate. Okay, we can run some of those angles and see how it's going to hit the side of the structure and run it. For our area, I'll tell you right now, 2.8 feet is the optimal size for our eaves. But that is subjective due to the roof slope. Okay, and the angle you have it out, because if I've got a 24-incher, it's going to hit somewhere. Well, what if I take my roof slope and do it here at 24 inches out? It's going to be down in here somewhere. And so keep in mind, I got a window over here. That's really primarily what I'm worried about. Remember, walls have about an R21, R22 rating. Windows have a very expensive window, has an R4 rating. That's your weak spot. These things will greatly, and we're going to do a little exercise on it. I'm going to push it back until Eli comes and talks to you, because he's going to address passive energy systems. And I've got a little exercise I'll ask you to do with that. You got a question, Cheryl?
Yeah. You mentioned that 2.8 feet is optimal. Is there a range of slope that it's optimal?
That's based on a 612 roof.
612,
Okay, now, there's a formula that we've got with this, but ultimately it works best when you just draw it. And you can do a quick search on summer and winter solstice based on Twin Falls, and it'll tell you the exact angle you're going to see. And I'll show you all that stuff when we do it. 3D software spends a lot of time doing this type of stuff. Okay. All right, let's go into our different shapes. Okay. Let's start with a flat roof. So page 555, and generally as we talk about these, we're going to look at it in cross-section. The author gives us a cross-section view and a plan view. So you're going to see how they're displayed in both of these fashions. Keep in mind, in today's world, we mesh all these shapes sometimes into a roof. You can look at one roof that might have a shed, a gable, a hip, and a gambrel all in. Okay. So we're going to change some of these shapes as we go on depending on what they use. There's an example of a flat roof. Now, what is the flat roof? I mentioned that it's not flat. Okay? Notice that on this drawing, this looks a little higher than the rest of the roof. These typically do have a slope, and it is usually somewhere around a 112. Okay? So a 112 slope. They will then, generally, here we got rain. It's going to shed to some place, and it will come into some pipe and be shed off. And you'll see this around, you walk around this building, you're going to see them all over. I think there's 4 or 5 of them around this building. In fact, I think we've got one right outside one of these windows here. I think it's that one, where you can see the roof drain comes out and kicks out on the ground. So this is going to funnel all the water to a spot, and then it'll go into a drain pipe and get shot off. Now, why would we use a flat roof? Why is it advantageous to us?
Space.
Why does commercial use this? Yeah, we got a flat surface. Okay, so if we need to get some stuff out of the living spaces, this is a great place to put it. And I might come in and I might have a big thing sitting here, and it's my AC unit. Now I'm not, this area down here, this cost me $130 at a minimum per square foot. Well, let's get that out of there so I can use it and put it up here. So we do see most of our HVAC equipment put up there. Now this building's a little unique. When this building was put together, our big mechanical room you folks walk by, that was put there for display purposes. Most of them is going to have all that stuff up top. So we can have that, we can have a lot of other things. I don't want to say just the mechanical equipment's up there. We can use it for storage, we can use it for other things. Yes?
Are you putting another roof on that to protect those things from the elements?
If they need protected, but most of them don't need protected. They're already in metal and they're out. I mean, your house probably has an AC unit that's sitting outside.
It's under these kind of,
Okay, yeah, but it's not protected,
yeah.
and the units themselves are protected. Electrical can go up here, a lot of different things. So here's your cross-section view. Turn the page and we'll get the plan view. This is in figure 2214. Now, I'm not really going to go into this, but when we build this roof, there's some examples at the end. This basically, you almost build it like a road. It will have tar up there, right? What we consider like your asphalt pavement. The stuff we use is not hard like a road, but it's in essence the same material. It's just given in a different fashion. So this has got to be tarred. It's still got to be waterproofed, right? So typically there will be a bunch of layers of what we call bituminous, or it's in essence tar. And then on top of that, you're going to see a bunch of gravel placed. The gravel is only there so you can walk across it. It's not really there for anything else. You know, on a hot day, you ever tried walking across the tar?
Yeah.
No.
Well, you leave your shoes behind, right?
Flip-flop first, yeah.
And that's why we put gravel over it. So if you go on most commercial buildings, what you're going to see is a big patch of gravel. Underneath that is a waterproof layer.
And they're getting away from gravel now, too.
Yeah.
Yeah, they're getting into different things. Certainly, these will all change, and what I'm giving you, let's just quantify that. That is a general thing. There's a lot, if you got money, we can do anything you want.
Is that what bitumen is? Is that, you heard that word?
Bituminous.
Bitumen, I thought they called bitumen. Is that paper that you roll down?
That's felt. Now they're kind of changing all that on roofs too. Now we basically use the same stuff that comes in a sticky roll.
Yeah.
When you guys say they're taking gravel off, what have you seen out there? So obviously you guys have seen something. What else have you seen on these?
On a flat roof?
Yeah.
I've actually done flat roof training
Okay. And
with
what?
GAF. So I have done TPO, PVC, foam, and a hot tar, but nobody does hot tar because it's expensive and it's dangerous. And people don't do torch downs anymore either for the same reason. Because you can't carry insurance on a commercial company and afford it to have somebody up there with a friggin' torch burn tar.
Yeah, like you said, they show here. That's creepy.
TPO has become the most common.
And what is TPO?
TPO is a thermal, it's a plastic that's embedded with polyester. So you have two layers. I've been to the factory for GAF, and they heat it together and it welds together, and then you actually use a machine that welds it. And if you have a completely flat roof, you put it over the styrofoam stuff that they make, and you can actually build the slope. And you can build, you know, crickets and little hips and stuff to make sure that the water flows away.
Okay.
But the most common, like, higher end one now is polyurethane foam.
Okay.
Because they just lay it on and then they just roll a coat of coating over it and then recoat it every 10 years and it lasts forever.
And that's fairly cheap. You will find, so maybe Google TPO and see some of the new materials. We're actually going into a huge revolution. The last 20 years, our materials have changed so much from previous years. Okay, so in essence, when you draw it though, here's what you're in essence drawing from your top view. All you see is an edge and a support, and you will indicate the down slope, because it will have a slope. The next roof, a shed roof. Here you see a picture of one here. In essence, what's a shed roof? It's a flat roof that's been tilted. And that's in essence what it is. So a shed roof is one tilted plane. You see it in cross section right below here. So this is the way you would draw that. Now a shed roof, we have some different components. These are done with trusses. A lot of times they're done instead with a rafter system. Now, rafter just means one board here. It's not a collection of boards like a truss. So it's one board. This would be a rafter, and we'll talk more about this also in structural. You might have purloins and girders. In this case, they're using a wall to support it. You could have a beam up here. Yes?
Can you essentially put a shed roof on, connect to any type, any style of roof that you want?
Yes. Yeah, in fact, I think your client drew you a
Yeah.
couple shed roofs
Yeah.
that they want on theirs. So we're gonna do shed roofs. These are real popular for overhangs on porches, for any device that's fairly small. A shed roof is easy to build. You don't have to go pay somebody else to really do it. You just basically throw stuff up there and cover it.
Doesn't have to be engineered, stamped.
Well, yes,
That's-
technically. If I'm doing a bully barn, no, I'm not gonna go get this done, but for a structure, yes. I mean, if you did. As long as you've got outside the prescriptive numbers, I should add that. So in essence, here is a shed roof. Okay, so you'll have two supports and a slope. Okay, the slope is given with your little sign. So think of a shed as a flat roof that's been tilted up. Let's go to figure 2218, right here. When you're looking at your plan view of a shed roof, it's identical to a flat roof. But now you're looking at more of an inclined surface, right? This looks just like your flat roof, but it's a shed. They need another view to determine what this is, right? Hence an elevation or a section. Here's that same one you just looked at. This one looks like what our next roof, which is a gable, but in essence it's two sheds. Keep in mind, they do need another view to really determine what that is. So your shed
They need
roofs.
another view for the shed roof?
Yes. Well, for all these roofs, you're gonna get other views. All right, our next roof. Probably our most popular roof in Idaho. Two sheds joined at the middle. We call it a gable. So we're morphing this now, and we're joining it together. So in essence, a gable roof is two sheds that are joined at the middle. So two slopes. Here you see a whole bunch of them. There's a gable, there's a gable, there's a gable, there's one, there's one. The side views are gables also. This is an entire gable roof structure. Except for the front porch, which is a hip setup. When you look at it in plan view, here it is right here. It looks just like that shed, but now you will have a center line that's a ridge. So that's a new line that's been interjected. Instead of just edges, now we've got ridges. When I have two gables that intersect, I get a valley. This is a valley right here. Maybe you might just want to write that right in the text. That's a valley. So is the one on the other side. This is a valley. Yes, Cheryl?
These all have down arrows, but the original one you showed us did not have any arrows?
Yeah, the author's just putting it down for your
So
use.
that's for us, okay.
Yes, it's not on the plan. I shouldn't say that. I've put it on the plan before when I have confusing views. You know, I kind of go a little bit above. Yeah, it's not required. That'd be a good way to put it, Lisa.
Okay.
You kind of see the cross section of the gable right below that. Okay, now keep in mind, most times when we do this, it's not going to be like this one. It's going to have a truss sitting in here, right? Where I've got maybe a W truss plan or something like that. There's a bunch of boards in here holding this up. And again, I will talk about trusses more at the end. Yeah.
Kind of a sidetrack. Are we gonna have a block or standard, you know, when you draw a plan like this, show to to your client, or do they want the trusses drawn in there?
Yeah, typically we draw them in.
And even though they may not be exactly how they're gonna be built, but we,
They won't be how they're
yeah,
going to
so,
be
but
built.
there's a, okay, so there was a plan, and when you said the W thing, it's like, oh, it must be something we're supposed to.
We throw them in there, and when we put a note on it, it says, "Trust designed by others."
Okay, you show it, right?
But it is a truss.
Okay.
So they can recognize that that's what it is. All right, a gable. Now, why do we use this one so much? It's the most economic roof we got. They're easy to build, they're cheap. You might think that if I'm doing this with a truss and I've got a 412 pitch, which this thing kind of looks like about a 412, or I put a steeper roof on here, which one's going to be more expensive?
Steeper.
You would think so, but that's generally not the case.
Really?
In actuality, flatter roofs cost you more because it takes more lumber to carry. The steeper you go, the cheaper they get, except that there's a break even. And it usually happens right around that 6 to 812 roof. Those are generally your cheaper ones. And then the real steep ones are expensive, the real flat ones are expensive. There's one other thing on all roofs that kicks in. When you get to an 812 slope, OSHA kicks in. Okay.
It's in on where?
Kicks in on the
812.
codes,
On which ones?
on an 812. By that, roofers, by the way, which is the most dangerous occupation in America,
Yep.
they are not susceptible to OSHA on a 712 or below. If you get to an 812, now they got to have fall protection, they've got to have guards while they build it, and all of that kicks in. So your 812s and above generally get a little more expensive because they're going to cost more to build. Now, have you all seen people out there on greater than 812 roofs that aren't roped off?
Yeah, Brittany from Trusty Trucks, yeah.
Oh, yes. I actually watched a framer in Sun Valley once, and he was a mountain climber, and the guy was standing on the top of the trusses and just walking them and doing all his nailing.
Oh, I
And they weren't even
remember.
supported.
I left,
Yeah.
I can't watch you guys, I'm weird, it's gone.
But yeah, all that kind of, do they do it? Yeah, all the time, but that company's susceptible to a fine if they get caught. Right? And that's out of our hands, right? We don't have anything to do with that. Yeah.
So would that be like specified as soon as they like get the blueprints or something for that?
No, it's something they gotta know. We don't have to put it on there.
We don't.
Nothing's a problem, right?
No, it's the company's fault, not ours.
Okay.
They need to know how to operate. We're not the policemen of them.
Okay.
That's why we have agencies like OSHA. All right, so that's a gable. Next one's an A-frame.
Oh, A-frame.
We've all seen these. We kind of depict them as cabins in the mountains.
Yep.
An A-frame, what is it? It's a wall that's been tilted to form a roof. That's in essence an A-frame. This is built like a wall, usually goes clear to the ground, and is tilted over to join at the middle. This is not a truss system. In essence, many times there's not even a beam. They're just held together by their own weight. Real good roof when we got very extreme climates, especially a lot of snow. Now, if the snow builds up on here, what does it do? It insulates the structure, right? So in essence, you make it more efficient that way. Certainly, we impact our interior spaces with this because we're no longer straight walls on the outside. They're all leaning in. If you look at it in plan view, in essence, it's the same as a gable. So I'm not going to go there. They do give you a good section view right here in 22, 23. Generally, they don't have to be, but most of the time they will be multi-floored because generally we do have to have a mid-span here just to kind of hold it. We're not going to trust just gravity to hold it together. So that's an A-frame. Looks just like a gable though when you draw it from the top view. Next one's a gambrel. Here you see a picture of it. Make sure I'm not missing any of these. Gables, apron, yeah, gambrel. Okay, so you see a picture of it in 22, 24A. Also in 24B. Does this look familiar to Twin Falls?
Yeah.
It's a barn.
Some of them.
Barns, I mean, you see barns like this all the time, right?
Yeah.
Anybody drive through Old Town very often?
Yeah.
There's a lot of houses in there that have this type of shape. A lot of them. In essence, it's a multi-pitched roof. Okay, so we combine separate types of pitches with this roof. Typically, it will go flat off the top and then drop at a steeper angle coming through the side. What we use this for is to create space inside the roof. It's used to create that space. So that's a gambrel. You saw a lot of these in the old days when we built stuff by hand in the kind of the ag arena, because you could really build it like a tilted wall, an A-frame, and then a gable over the top of that. And that's the way they would build them. Today's world, we can buy trusses like this. Okay, so you can bring it into the residential market and have it be in a truss system.
So do you think for somebody that's, like my grandfather built his own house, and is this style easier to build than just a straightforward gable?
No, because you're doing a gable and an A-frame, right? Because you now got your sloped side, which probably is a wall of some portion, and then you're putting a gable on top of it, and they're really combining both of these and calling them a gambrel. Right? So I don't know that it's easier. The primary reason is to get space in here and use it. Because if we did a gable on this, keep in mind it would go right through here, right? If I did a gable, it would go like this. And so I wouldn't have this space that I could use inside.
Or you just bring a roof up and you go like this. I mean,
Then you gotta go higher.
Bring a wall up and bring it in.
Then you gotta go higher.
So it would probably them spaces.
Yes. And think of, Andy mentioned barns. What was sitting upstairs in barns? Hay, storage, right? Okay, so they put it up there and then they throw it off down a hatch to feed the critters. So we needed that storage space. I think it's a pretty cool roof myself. I kind of like this roof. Never built one, but maybe one day. When you look at it from plan view, it is figure 2226. So you see some pitch breaks, so you need to describe those. So here's the flat section, here's where it goes steeper, here's my support all the way around.
Now it's called a curve.
What's that?
Now it's called a curve. Curve.
Uh,
Ridge.
Edge.
Well, it says curve.
Where? Oh, roof curve? Oh, where the pitch breaks? Yeah, I don't know that I've ever used that term, but I guess you could.
Whatever. Just-
Okay. Works for me.
But I mean, why did they not call it a ridge? Why did they call it a curve?
I don't know.
So you call it a ridge?
I call it a ridge. Next one, hip roof. Hip roof, denoted by just a simple term, all edges slope. All edges slope. Primarily, why would I use a hip roof? To reduce the mass of the roof. A real common roof in today's world. And by that, when I say reduce the mass of the roof, how many of you have seen houses that look like this? And let me draw one here. So I got a house, and then my roof looks like, because it might be a wide house, my roof looks like that. It's 3 times as big as the house.
Yeah.
And if you get a wide house, that's going to happen with a gable roof. So what people have started doing, now that we have truss companies, now certainly they built hips in the old days too, but it was pretty expensive. Now we can do a hip roof where we slope it both ways, and my roof looks like this for the same structure. So in essence, use hips to reduce the mass of the roof.
That looks like a mess. I mean, that's too much going on top. I think.
Picture roof up.
I mean, that's a heck of a lot of stuff going on.
Yeah, but it's real common in today's world. to do that, because what are our houses? They're getting bigger and bigger and bigger and bigger all the time, right?
I thought we were going downsizing now.
Nope.
Small house, they can kind of.
No, not really.
It's like
Yeah,
that.
only in the cities where you watch, what's her name, Yuki or whatever, that has that small house little thing on it.
Yeah.
And they write articles on it. No, if you look out in America, I think generally our houses are getting much larger. I mean, how many of you can tell stories of your grandparents and stuff that raised 9 kids in a 2-bedroom home? Common, right? Common. Today, almost everybody gets their own bedroom, right?
Yep.
And that's just the way we go. And our families have gotten smaller and our houses have gotten bigger. Be that good or bad, I don't know. You could argue that all day long, but it's just the way things go. We have more disposable income, in my opinion, in today's world. So you see stuff like this quite a bit more frequently. Hip roofs. All slopes go. Go to page 560 and you'll see the view of it. Here they compare the gable versus the hip. So this is the hip look here. So ridge, 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 ridge. Okay, they call them hip, that's still a ridge. That's a ridge. As opposed to a gable, we got valleys, right?
Yeah. Well, that's.
By the way, what angle is this line? Anybody know?
45.
What's that?
45?
If the two roofs slope the exact same pitch, so they're both 612s, this line will always be a 45. Valleys also. If this is a 612, that's a 612, that will be 45. Okay, always. Because in essence, remember, you're looking down on a right triangle, that's a 45-degree angle. Now, if they slope differently, and we can do this in today's world where we make this one a 612, that an 812, now you're gonna have problems down below and how all this matches up, but this angle will not be 45 if the roof slopes go. I'll give you an example of that when we draw our roofs in a couple days and how you figure that out.